In this video, we are going to talk about vectors in 3 dimensions. We have the XYZ coordinate system. We have OX, this is the positive side. If we go this way, is the negative. OY, positive, this way would be the negative. And OZ, the positive one, and going down here it would be the negative direction of Z. The space XYZ, it's split, it is divided into 8 regions called octants. So we also have a convention, right-hand convention, and this is the best I could do. This is the thumb, and these are the fingers that are curled. So if the fingers are curled and they rotate from positive x-axis to the positive y-axis, then the thumb point in the positive z direction, and we'll use that information later on as well. Now let's do a few problems where we want to plot a few points in the XYZ plane. So we have the X, O, Y, Z plane, and let's call this point A. So we want to plot 3, 4, 5. So X is 3, Y is 4, Z is 5. So X is 3, 1, 2, 3. Y is 4, 1, 2, 3, 4. So this point here, it's the point of coordinates 3, 4. And now we want Z5, which means from here we're gonna have to go 5 up. So let's say this would be here 5. So this point here, these are dots. It's of coordinate 3, 4, 5. Let's draw B. B is of coordinates -2, so X would be this way. So 1, 2. Y is -3, so it would be in this direction. 1, 2, 3, -3. So we're going to find the point where these two intersect. So this one. And from here, we go up 5. So we would go still to 5, which is this one. So let's call this point B, because we go from here, but let's not forget this is in the plane. So basically it's something like this, and from here you go up 5. And I should go for 5 at the same distance that I went here. So if this was 5, then I'm gonna have to go 5 like this. So this would be the end of B, because these two, this plane and this plane, are on the same, at the same level, and from there we go up the same distance. Now let's graph some equations. So let's we have the plane XYZ, and we want to graph x equals 2. So the x equals 2 into XYZ. So x equals 2 would be here, and now that means y and z can have any values. So that means x can be only 2, but y and z can be anything. So that means the graph that, or the plane that is represented by x equals 2 is this one. whereas we can see y can have any values and z can have any values as well. And of course this expand, but we just represent it as a plane like I did before. Let's graph y equals 4 in xyz plane. So 1, 2, 3, 4, it's y, which means y can have only 4, while x and z can be anything. So then we would go like this with x. So if we connect the points, the graph or the region that its y equals 4 is this plane with green. That goes this way too. And finally graph z equals 3. So z equals 1, 2, 3. And so the plane that we have for z equals 3 would be, I'm trying to do a parallelogram here, so it would be this one. That is going through z equals 3, but it's basically parallel to the plane xyz, x, o, y. And so it looks like this to cover as well the negative values for x. So the graph of z equals 3 would be all this purple thing that it's parallel to the plane of x or y. But I extended it because we want the negative as well. A few quick formulas that, if you remember from 2 dimensions, work pretty well here as well. Distances, so the distance between 2 points that are in 3D. So we have x1, y1, z1, x1, x2, y2, z2. Then we have x2 minus x1 squared, y2 minus y1 squared, and z2 minus z1 squared. So this one shows up extra than we had in a 2-dimensional, and square root of that. The same with midpoint. So we had x1 plus x2 over 2. We had y1 plus y2 over 2. But we're going to have z1 plus z2 over 2 because we are in 3D. Same thing with spheres and balls. So remember, when we are doing circle, you had x minus a squared plus y minus b squared equals r squared. That was a circle centered at AB and with radius r. But because we're talking about a sphere, right? So let me just make a quick sketch here. Sphere, right? This is radius, this is radius, this is radius. So now the center has 3 coordinates, so it's going to show up z minus c squared as well. And this is the sphere, and so a ball centered at ABC is going to have x minus a squared plus y minus b squared plus z minus c squared less than or equal to r squared. So what's the difference between the sphere and the ball? Well, the sphere is just the shell, while the ball, it's all the points inside. So like you had a circle, right? But then you can have a disc, right? So for a circle you would say x minus a squared plus y minus b squared equals r squared. That would be the equation of the circle. And the equation of the disk would be x minus a squared plus y minus b squared less than or equal to r squared, to include all these points in here. So let's solve a problem. Consider the points P of coordinates 1, negative 2, 5 and Q of coordinates 3, 4, negative 5. Find the equation of the sphere for which the line segment PQ is a diameter. So let's find the distance PQ. So it's x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And that gives us 4 plus 36 plus 121, and that is equal to, this is 40, 161. So if we think about it, if PQ is the diameter, we can say maybe P is here and Q is here, right? P and Q. So basically the radius, it's PQ over 2, so it's square root of 161 over 2. So the equation of the sphere, for equation of the sphere, I need the center and I need the radius. So we did find the radius, but we need the center as well. So the center, it's given by the midpoint between P and Q. This is the center. So now we are using the midpoint formula. So it's 1 plus 3 over 2, negative 2 plus 4 over 2, and 5 plus negative 6 over 2. So basically in this formula we are using all the formulas that we talked about. So we get 2, 1, and negative 1/2. So having the radius and having the center, we can find out the equation of the sphere. Oops, mess up my work, but we have them. So then the equation of the sphere is x minus 2 squared plus, this is the 2, y minus 1 squared plus, this is the 1, z minus negative 1, so plus 1/2 squared, equals the radius squared, which is 161 over 4. So this is the equation of the sphere given the 2 points. Let's take a look at another problem. Describe the set of the points that satisfy the equation x squared plus y squared plus z squared minus 2x plus 6y minus 8z equals negative 1. The experience is telling me that this looks like the equation of a sphere, but in order to do that, we need to complete the square. So I'm going to copy these two together. I'm going to copy these two together, and I'm going to copy these two together. So it's going to look like this, x squared minus 2x. And to complete the square, I will have to, well, I'm going to leave a little bit of space first, plus y squared plus 6y, leave a little bit of space, plus z squared minus 8z equals negative 1. So now, half of this squared, it's plus 1, but I have to add 1 on this side to balance my equation. Half of this squared is plus 9, because half of 6 is 3 squared 9. Half of 8 is 4. Oh, and I want to balance it, so plus 9. Half of 8 is 4, squared is 16, so plus 16. So we end up with x minus 1 squared plus y plus 3 squared plus z minus 4 squared equals 25. So this is the equation of a sphere centered at 1, -3, 4 with radius 5.